So hello everyone. Today I will be going to discuss about different types of flow meters and and their conditions and their advantage, disadvantage, and how they functions. Uh, First of all, we'll be discussing about different types of the flow meters present in the industry. First is the positive displacement. This depend upon the phenomena of displacement that is in the positive direction when the liquid is flowing through the pipe. Now then again, second one is the electromagnetic flow meter, which depends upon the electromagnetic condition. It is depending on the Faraday's law of electromagnetic conduction. And then there is ultrasonic flow meter, which is depending upon the ultrasonic sound in the device, and this ultrasonic sound helps in configuring out the flow rate of the flow meter. And then this is the differential pressure. This differential pressure type is basically it is defined the flow rate according to the difference in the pressure between the 2 points by using a diaphragm. And then this is the Coriolis mass flow, which depends on the basically it is a type of the flow meter where we can detect the flow rate by using a particular pipe, which is sensing pipe, I can say, which senses the flow at a particular point. Then there is the vortex type, which is another type of flow meter. So first of all, we will be discussing about this positive displacement type. Here the positive in that positive displacement type, we will be looking to this video. There we will look at this, and when the flow is coming from this direction, the liquid will be transferring to the opposite direction again. In this is the bulb, we can say. When the flow comes, it gets directed towards this, and another bulb also directs the flow to this direction. So it is a positive one-way direction. So this is the positive displacement flow meter. And here we can see the advantages. There's a different type of advantages of the positive displacement type. So the first advantage is that it is independent of the viscosity of the liquid. The liquid is here is independent of the viscosity. The flow meter works, let it be heavy oil, let it be coal, or let it be any type of liquid. It will work in every aspect. And then there is a independent of density. The second point is the independent of density. The density of the liquid is not dependent upon the functioning of this flow meter. And then this is independent of temperature. So this can conduct this can be used to determine the flow rate of a liquid having a different temperature, let it be less, or temperature maybe it can be high. So this is the three advantage. The fourth is the very precise measurement. So here we can see that the measurement which is taken from this flow meter is very specific, and it is very precise, because we can say there is no error in this particular phenomena. There is no error can occur because it is always working at the same position. And then we can see this fifth, there is advantages that used for highly viscous dirty fluids. So we can use it in the sewage system where the fluids are very dirty, and we also can use it in many different aspects and different cases. So there are few disadvantages also of this flow meter, and that is the positive displacement type. There is different disadvantages are that for the first disadvantages, for large pipes it's expensive. So we cannot conduct it for a very large pipe because this can take a lot of amount. It is a lot more expensive. Then the second one is this: with the low viscosity fluids, accuracy is very less. So it only applies on the high viscosity fluids. So then the third one is the sudden change in the flow may damage moving parts. So there is a moving part here available, so we can check out this moving part can have any type of wear and tear due to the sudden change in the flow. So we have to take precaution of this. And then there is a not suitable for sticky liquids, like we can say this, like a liquid like Fevicol or anything like this, adhesive liquids. These are not applicable here because it is a moving part, so it can cause damage or irregular measurement. And then this is fifth disadvantage is that it has moving parts. So as I have said, the moving parts are prone to damage. And then that creates a pressure drop. The sixth one is it creates a pressure drop in the flow. Now the second type was the electromagnetic type. In the electromagnetic type, the principle is it works on basic principle of Faraday's law. So here we will be studying about the Faraday's law. We have to get a basic idea of this. The Faraday's law of electromagnetic induction, which states that when the magnetic field linking a circuit changes, an EMF is induced in the circuit and is proportional to the rate of change of the flux. Here what it says this, the EMF is changing when the rate of change of the flux is uh, the first time we can see this is the magnet is working properly. If we get closer to the coil, there is a disturbance, and this disturbance leads to the cause of the sudden change in the voltmeter or emitter present there. This can occur some changes when the magnet is closer to the coil, and when it is outside, then it's again gets to the stable position. So the Faraday's law works on the basic principle of the magnetic field that is linking to the circuit is changing. Always it gets changed, and it is proportional to the rate of change of the flux. So the flux which is created there gets changed when the magnetic field is or the magnet is in the coil. So this is the basic Faraday's law principle. And then we can also see this here in this animation. We can check out that how the electromagnetic type of flow meter works. So here we can say that when the liquid flowing through the pipe, then there is two electrodes which senses the electrode senses the 2 points senses the flow of the liquid, and hence uh, it can measure the flow rate. So we can see that here these two electrodes are the north pole and the south pole of the magnet, and then we can calculate or we can detect the change in the flow rate at the time. So this is how the electromagnetic flow rate works properly on the basis of the Faraday's law. So here is few of the advantages and disadvantages. So first of all, we'll check out the advantages. The first point is that it is independent of the viscosity. The second is the independent of density. Then there is independent of temperature, so no pressure loss takes place because it is pressure prone. And then there is a large measuring range. We can measure to a high level of range. Then this is suitable for viscous and slurry fluids, and also it is suitable for high and low flow. So this is a few advantages, and few disadvantages are like can only be used for conductive fluids, and because it is working on the magnetic principle, so it can only be used for the conductive fluids. So this is the few disadvantages. And the second disadvantage is that its installation and commissioning is complicated. So this is a few of the disadvantages. And the third disadvantage is that dirt stick substance stick to the electrode of the measuring tube, so give wrong reading. So when such a dirty things and the fluid gets stuck in the electrode, it can lead to a wrong measurement of the wrong reading in the reading meter. So this is the few advantages and disadvantages of the electromagnetic type. Now the third is the electrosonic. It is the ultrasonic type. This is ultrasonic type. It basic function is the ultrasonic sound is sensed by the opposite direction. It emits the ultrasonic sound and it sends down here. So this is the basic phenomenon of Doppler effect. Nothing but a Doppler effect. We have to study about the Doppler effect to get to know about the ultrasonic type. How does it affect? So what is the Doppler effect? An increase or decrease in the frequency of sound wave as the source or observer moves towards or away from each other. So we have seen this is the particular object and this is the vehicle. When it comes towards the object, it gets the sound gets closer to the object, and the sound gets higher, the frequency gets higher. When it's away from the object, the frequency gets lower. So this is the basic phenomenon of Doppler effect. And we can see this, the car is moving towards the source and the stationary object is there. The Doppler effect phenomena takes place here, the sound source moving towards the observer. So we can check out here, this is the Doppler effect phenomena, and it basically used in the ultrasonic type. So in the ultrasonic type, the flow meter are sound waves and nothing but there's the sound waves, and at no flow condition the frequency of the ultrasonic wave transmitted and reflected is the same, because there is no flow, so the frequency is always the same in this pipe. And when under the flowing condition, the frequency of the reflected wave is different due to the Doppler effect. So this the Doppler effect takes place when there's liquid flowing through this pipe, and then the fluid moves faster, the frequency shift increases linearly. So when the fluid moves faster, the frequency shift also increases. So there is a some advantage and disadvantage of the ultrasonic type, and some advantage you can check out here is no moving parts is there. So this is the few advantage, and no additional pressure drop and no obstructed flow passage, and there is no there's a highly accurate, then no contact with liquid, then affected by properties of fluids such as temperature, density, and viscosity. So these are the few advantages, and now we will see the disadvantage of this ultrasonic type flow meter. The few disadvantages are like expensive as compared to the other, and dirt can impact the performance. These are the few disadvantages of the ultrasonic flow meter. So now we'll be heading towards the differential pressure type flow meter. So in this case, what we'll be looking here is the Bernoulli's theorem or the Bernoulli's equation. So we will have to understand the Bernoulli's equation in this particular type of flow meter. Here we have to, first of all, we have to know about the Bernoulli's equation. What the Bernoulli's equation is, we have to just taking away by taking a pipe, we will understand this Bernoulli's equation. So this is a pipe, and there is some constriction in the pipe. So here the point is P2 and there the point is P1. So what will happen is, like in these 2 points, the area of this point is very much larger than this area of this point. So what will happen is the velocity, this flow of the velocity of the liquid will be v1, taking it as a v1, and velocity here is a v2. So the velocity will be less in this case regarding to this case, because the velocity at the area is higher, though, so the velocity at that point will be very much less. So we will look into the matter. If the area is a1 here and the area is a2 here, so the velocity will be v2 will be greater than the velocity v1. So, and indirectly this velocity is indirectly proportional to the pressure at that point. So the pressure will be P2, that is pressure at the point 2 will be less than the pressure at the point 1. So the pressure at the point 1 is very much high than this pressure at the point P2. So this one we can get by comparison method. And now we have to understand this equation of this Bernoulli's theorem. So equation, it states that at the point 1 the all the summation of the kinetic energy, potential energy, and the pressure energy will be equal to the kinetic energy, potential energy, and pressure energy of the point P2, that is the point 2, will be equal to each other, because here we will see that the energy per unit volume before will be equal to the energy per unit volume after. So here in this case we have seen that this 2 points summation of all the energy will be equal. So now heading towards the Bernoulli's equation, the flow rate measurement. So heading towards the flow rate measurement by taking the horizontal flow, that is taking the pipe as a horizontal. So if we take it in horizontal, for the horizontal flow if we take, then for the horizontal flow we will see that the height will be similar for both the cases. So height h1 is equal to height h2. So here what will happen in this equation, we will get this height h1 is equal to height h2. That means these two height are equal. So we will cancel it out from this equation. We will be getting this equation. So now after getting this equation, by assuming the conservation of the mass, that is q is equal to a1 v1 is equal to a2 v2, by taking it we will substitute, and after substituting we will get the q will be equal to a2 square root of 2p1 minus p2 divided by rho 1 minus a2 by a1 whole square. So this is what we'll get after substitution. So if we measure the pressure difference between the point a1, this is point 1, and to point 2, we have got the flow rate. So this is how the flow rate is measured using the differential pressure type by using the Bernoulli's theorem. So in the case of the differential pressure type, what we can see, this is the animation of the differential pressure type of flow rate, this flow meter. This is the flowing of the liquid here. So in this case we can see this, the Bernoulli's theorem is working out, how the principle of the Bernoulli's theorem is affected here in the differential pressure type. So here we can see this is the high region of the high pressure and the low velocity, and there is the region of the low pressure and high velocity. So this is the Bernoulli's theorem working principle here, and we can check out the advantages of this differential pressure type. So what are the advantages? The advantages are, the first advantage is this: the universally suitable for liquid, gas, and steam. For all type of substance it is suitable, and suitable for extreme temperature and pressure. It is also suitable for extreme temperature liquid, or extreme temperature gas, or extreme temperature steam. And it is also a low pressure drop for nozzles. There is a low pressure drop for nozzles. We can Now we can conclude to the disadvantage of this pressure type. Now this differential pressure type having a few disadvantages, like the very long inlet and outlet installation, due to which the expense gets high. So we can check it out here, and the high maintenance is required for this, and affected by pressure density and density changes. So if the pressure density changes, it get affected, and that's the reason for which it is getting different value of the measurement. So there's the few disadvantages of this flow rate. Now this Coriolis mass flow meter. Now in this case, what is the principle of this Coriolis mass flow meter is that the principle, it works on the principle of the sensing element, which is located in this 2 point. So what is the sensing element does is this pipe is a moving pipe. This is the moving pipe, which is very much flexible pipe, we can say. The phase shift, it basically works on the phase shift, which the phase shift is linearly proportional to the output derived from this output which is derived is linearly proportional to the phase shift which is taking place here. So this is the basic principle. So we'll check out the principle here. When a gas or liquid passes through a tube, the mass flow momentum will cause a change in the tube vibration. So this is the vibration of the tube. So when a gas or liquid flows, the mass flow momentum will cause a change. So now the tube will twist, resulting in the phase shift. So when this tube is twisting, so there is a change in the phase. There is a change in the phase or shift, phase shift. You can say it is phase shift. So now this phase shift is measured in the linear output direct proportional to the flow. So this phase shift which is taking place here is directly proportional to the flow of the liquid. So now this measurement mass flow independent of what is within the tube. It can be directly proportional, directly applied to any fluid flowing through it, liquid or gas. So it can be applicable for any type of fluid, let it be liquid or let it be gas. So this is the few principle of this Coriolis mass flow. Now the advantage and disadvantages of this. So here in the animation we can see that the phase shift is directly proportional to the flow. Now this is the sensing element which causes the which measures the phase shift. So now this is the advantage and disadvantage. So what the advantage is that it is accurate mass flow measurement. So the measurement of the mass flow is very much accurate, and very high accuracy is there, and unaffected by pressure, temperature and viscosity. So this is the few advantages, and operate in both flow directions. So it can operate in two flow direction, from one end to this end, then this end to this end. It can work for both. So now measuring range setting can be optimized. So the measuring range can be optimized in this flow meter. Now the disadvantages, very few disadvantages you can find it here. This, it is affected by gas inclusion. So the gas, if it get contaminated with the gas, it get affected in the reading and the measurement. So we have to take care of that. And the vibration sensitive when improperly installed. So it is sensitive to vibration. So if we give an external vibration in this, it get sensitive to it. So due to the sensitiveness of this towards the vibration, it gets the result gets different, or the measurement is error, having some error in the measurement. So this is the few disadvantages of this Coriolis mass flow meter. And now we'll check out the vortex type. In this vortex type, what is there is the advantage of this vortex type is like first of all we have to understand what does this vortex type principle works on. It works on the bluff body. This is the bluff body which is obstruction, and this bluff body is there, and in the flow or the direction of this liquid or the gas, there is the bluff body present out there, and there is the DSC sensor which senses the element, senses the flow rate of this element. So now in the bluff body we can see that if high velocity is there, so it produces the vortices. These vortices are sensed out by the sensor. So now the vortices produced due to this bluff body, and this vortex is high for this high velocity, and the medium for this medium velocity, and very low for this low velocity liquid. So it works on this principle. Specifically it works due to this bluff body, with the vortices which produced are sensed by the element, and thus the rate of the flow of the liquid is dependent upon the vortices, number of the vortices. So here we can check out this. And now the advantages. So no moving parts is there, so it is very much advantageous because there is no moving part present there, and a wide measuring range. It can be used for a wide range of measurement, and now unaffected by pressure, temperature and viscosity. So it is obviously unaffected by every aspects from every factor, because it is not involve any type of moving parts here. So there is no moving parts, so it is more advantageous. As the moving parts, in some cases we can see there is a wear and tear, so due to pressure and viscosity it get affected. So now there is a measures flow of all liquid, gas and vapors, all the three type of substances it can measure. So high accuracy and low maintenance, so it requires very low maintenance and its accuracy is very high. So the disadvantage of this is the external vibration can cause error in the reading. And the previous case we have seen that the external vibration is produced causes error in the reading, and now it's a high flow velocity shock can cause error in the same case, and not suitable for pulsating flow. The pulsating flow is not suitable here. So this is the few advantage disadvantage. And now thank you for this. I've shown you what type of the flow meter are there and their advantage and disadvantage with their respective principles. So thank you.